Yeah. Thank you, Daniel. Okay. Thank you, everyone, for coming here and listening. As Daniel presented, so actually I'm linguistic, the background, and spent quite some time now in machine learning field, but I'm not a real expert there anyway. What I wanted to tell you here about is how we at SEAL work with classifying legal documents. And in order to do this, I'll actually focus on two main topics in this talk. I would like to talk something about data cleaning and something that we haven't heard so much in the presentation, a lot in the machine learning community, but how do you work with imbalanced data sets? And how do you machine learning in those imbalanced settings? But before I do that, I actually would like to give you some background of who we actually are. If you haven't managed to come to our booth in the lunch, you'll hear. So, SEAL Software. It's a relatively new company. It was founded in 2010, and our R&D department is actually here in Gothenburg, so all the development is done here. Currently, we are around 50 developers, of which there is a very strong team of 10 machine learning specialists. So I'm one of them. Then we have our headquarters here in San Francisco, and we have other offices in London, in Munich, in New York, and also quite a big office now in Cairo. And we're around 200 employees. We have this product which is called Contract Discovery and Analytics, and there is this, the website that you can visit. And now, what do? We actually provide tools for our lawyers to do their job quickly. Not this kind of tools, more like tools that they can actually solve their day-to-day tasks. Our customers are actually, I should have actually put here a list of customers. There are quite a lot of big companies, the Fortune 500 companies. And what they have is thousands, in some cases, really millions of contracts. And it's not feasible for them to actually manually review contracts. So not only they even don't know where their contracts are. So it is very important first to find those contracts, do an analysis on them, and actually give them the other tools to actually be able to solve their problems. Like, I'll actually mention some of the problems that they may have. But one of this thing, but before I go to that, is just I want to say I have criticism sometimes, like when people, what do you mean by a contract? So when I talk that we are actually analyzing these, I just want to tell you that this is an agreement between two parties that is bound by some legal, enforced by law, and then this concerns like what rights and duties the two parties have. So just this is the definition. It also can be either written or it can be spoken agreement, but anyway, something that is enforced by law. And this is how, actually this is the mouse goes, but master service agreement, and just a few concepts so that you know, because I'm gonna mention a few more things here. We have some contracting parties here, Computer Science Corporation, and we have a starting date of a contract, which is here, June the 1st. Now, what we have is like the important thing for our customers is really to find some key pieces in their contracts. And here, would like to identify it with two use cases. One of the things that we have is this mergers and acquisitions. So think about the Pac-Man there. Over there, we have a big corporation and they want to buy some small companies, merging them into their own domain. And they really need to identify a lot of risks that are coming with this. Risks like, for example, we have a standard way of writing our clauses. Now, this other new company that we have just acquired, they have their own way of doing the things. So there may be a risk in case of court, in case of some lawsuit, they need to be aware what is the differences and really do a unification across the two companies, so that everything is the same way as it should be, so that they don't stand any chances of being sued in a court or whatever it is. So we provide them this opportunity to actually identify things that are non-standard in the new acquired company, company. They can have so I'm throwing here the terms like the entities, the termination dates. They really identify that, and they need to rewrite, update, consolidate all these things. So this is a very huge case for those Fortune 500 companies, which really need to, when they do the mergers, when they do acquisition of new companies. Now there's another tricky also point here, which is under the contract renewal. So every contract, or quite a lot of them, actually have the clauses that automatically you will be reviewed and renewed the contract. So basically you are gonna pay maybe someone for 1 year of leasing their land or something, or will pay some more money to someone else. Now, suppose that you actually don't need their service, but you forget to actually cancel the contract before the renewal date. You'll actually spend 1 more year paying to this person without actually using their services. Especially this has been very critical for the telephone masts, for the wind turbines, for any of those things where they want to just dismantle something, change something, but the land which the company has been using is still sending the bills and say, okay, yeah, we have a contract, it still goes on, you haven't canceled it, so please. And if they don't identify those contracts that have run out, and they have been renewed again, so they will be paying a lot of money, losing a lot of money without really needing. So yeah, so to avoid those renewal for life thing, we help them to identify the contracts and do some action on that. Now, how do we do it? So I said that we're working with contracts, and very simple thing. We have agreements, contracts coming in, and we do a classification pipeline. Out of this classification pipeline, every document comes with already an analysis, and we can identify the contracting parties. For example, I just given him the start date of the contract, the termination date of the contract, and so on. So a lot of other things there, which the lawyers can just see, filter, clear, whatever. They can then rewrite and do some action on that. Now, the way we do the classification pipeline, or at least one of the parts in the classification pipeline, is we have a machine learning tool, which we call Walrus. Don't ask me why it's Walrus. It's Walrus. And as every machine learning, whatever algorithm, it needs actually 2 things, maybe labeled and a lot of unlabeled data on which we trained. Now, I would like to concentrate exactly on the labeled piece for those 2 topics that I actually wanted to talk about, the data cleaning and about the imbalanced data set. Now, we need, of course, labeled data. And in our domain, the data comes, of course, in quite a lot of shapes. So we have things like, PDF, Word documents, emails, scanned. We have handwritten data. It's really like a mess. And because we have that thing in our customers, we also need to represent it in our label data set. Also, because we work with so many different customers, it's very natural we have a mixture of languages. So our documents can be written in one language, but the worst case is when you have actually multiple languages in the same document. They can come in 2 tables, they can come paragraph 1 language, next paragraph another language, and so on and so forth. And it's a nightmare. So what is the language of this document? And then also what kind of learning algorithm, what kind of pipeline, what kind of analysis will actually apply? Will you apply an English analyzer, will you apply French or German or Dutch or any of those? Now, there is also, when we're talking about the contract actually really is a very complex thing. It can consist of one main body, the master service agreement, then it can have attachments, schedules, other things they are following. But it's sometimes what we get in our system, it can be also things like just half of the contract. It can be just 1 page of the contract. That's how the customers have it. A 100-page contract can just become 100 new documents. So it's virtually 1 document or 1 contract, but it's like multiple documents. Because the way it's coming, also a lot of the source and the formatting is being lost, remove images, and we have OCR noise introduced. And talking about, like, if some of you listen to the adversarial talk there, we have seen a lot of things which the human eyes have been fooled with. For example, we have had contracts, probably because of the OCR, where every word is split into every letter with a small, tiny little spaces in between them. So we visually can read the letters, we can read the whole contract, but it's actually, there are basically no words. They're just tokens. They're just characters, character space, character space, character space, character space. And we have to sometimes work with such data, which is really, this is how we actually can fool the human eye. And we have data which is annotated with that one, but it breaks a lot of things. Our contracts are also extremely varied in length and size, and some of them are like over 1,000 pages long, which is also a problem. And yeah, the domains are varying. We have high tech, we have medical, we have electrical engineering, we have telecommunication, stuff like that. And of course, we know that lawyers like to obfuscate things. They want to make it very difficult for, so you really need to stand a chance in court. Now, because we have this data in customers, we have this data as our labeled data set with which we work. But to work with such data set is a difficult task. In addition, it's also specialized. So you need domain experts, like those two guys here, or three. And because they are domain experts, they actually introduce errors in the task. So we've noticed that in our label data set, we have somewhere between, it depends on the different labels, we may have something between 5 and 25% errors. And this is very important to actually identify that. And because we use the domain experts in our system, they actually sometimes have the mindset of thinking, well, I'm not married to the annotations I'm creating. So we kind of interpret it in several different ways, but one of the things is that, yeah, I can change my mind, yeah, sure, just like, which is, wait a second, I just want a black and white. No. Yeah. So, and because we have those human annotators, they introduce errors. For example, you label some data, but you have some missing labels. You just forgot to, what was my idea here was that you just didn't label some things. You not only that, but you put the label on a different category, and I'll give you an example. And you just misplaced the labelings. You basically put a label onto something that actually doesn't have. Something was a pear, but actually put the label pear onto a motorcycle. So it's not a pear, it's nothing. So yeah, and here is an example so that you can really see. I've already introduced what contracting parties is. And then we have the jurisdiction. So in which courts, what's called the dispute will be handled. And now, if we have this agreement is made between the state of California, state of New York, and the jurisdiction should be the courts in the state of California. Now, the courts in the state of California was marked as a contracting parties, which clearly it's not. We have two other examples here in our training data set, which says, oh, this is the jurisdiction, the court in the state of New York and the competent court in London. Now, if we have a test example like that, we'll identify Yahoo and Amazon as contracting parties, but the courts in the state of New York is highly tricky, and given enough context there, it should be, most probably will be identified as contracting parties. So these are the things that we actually need to handle and to take actions against. Now, I said that we have a lot of difference in domains. We have, as I say, we can have high tech, we can have telecommunication, we can have health industries. Now, and they often operate with the same kind of category. Let's say we have some legal category, like, for example, assignment. Assignment which determines whether you can give the rights to someone else to do whatever they want. Or you, under certain condition, or you don't allow them these rights. Now, assignment, when we thought that in our data set we have very good distribution of the clauses, assignment clauses, so we are pretty sure we had a very good model and stuff like that. Now we come to a new customer, and the first thing is our models just crashed totally. No, they're just wrong. This what's going on here. So when we have to do this by using different k-means, LSI, just visualize the data set, the distribution of the data set. And then it becomes obvious, the green ones are those that we had in our training data set. And here is their distribution, much more fine-grained. And then we see that the customer, it's the blue one. And then we say, oh, no, let's take, and it's really wrong. So we didn't take, and our lawyers probably didn't see that when they actually provided us with the data set and was aware of the customer, so this is it. So this thing was kind of really opened our eyes in about our own data set. And then it was so is that, I mean, as we don't have actually numbers. Like we always try to repair it immediately, like retrain the model, update the labels, update the things that we. But it is very important, and this is a paper, automatic training data cleaning for text classification, where in similar settings, news items, actually quite a lot, 12,000, that initially when they did their classification, they got relatively okay, not well, I wouldn't say so okay, but actually classification in the two, 60% almost, and F-score. Now, after they actually did the relabeling and put effort, like using, so you can see here, there's almost like a 15% increase in the F-score in one of the sets, and about 8% increase in the other one. So there is a proof that you should put effort into cleaning, like visualizing, analyzing your data, and just cleaning it. And this is what I want to just conclude this first part about the data cleaning. How important is that you really should actually revise your labels. You should really think about your data. You should re-annotate data, just like visualize it, review it, clean it. You should strive for this, the so-called inter-annotator agreement. In our case, it's of course sometimes can be hard. Having 2 lawyers already creates problems. Having 3, even more problems. But people have shown that people tend to agree with each other around 95%. And also, what I wanted to show with those with the domains is like you need to really diversify your data. You should, like when you add a new domain, you add new sources. You should also again revise your definition. This definition of a label of whatever we want to find, does it still stay the same in the new domain? Do we need to revise the old ones? Data should be like live. The worst thing that can happen is the data stays stale and doesn't move forward with the new things. And this is also what is very important, just to coming for the next one, imbalanced data sets. Now, before I proceed, if I ask someone, okay, so you want to create some, you're going to train some machine learning model, you need some label data set, what do you think? I'll have some negative classes, some positive classes, and in your mindset, you'll probably say, yeah, this part here is my positive and this part here is my negative. I wanted to come here, but I'll actually do this one. And it's not the case. It's this, what you see here is definitely not. What we see here in our data set is something like that. You have a lot of negative cases, a lot. And you have, even that's not even representable of our situation, when you have actually a very tiny positive. Now let me give you an example here so that you can, you have a random agreement. I just took a random agreement from our 26 pages, 14,000 words, 370 sentences. Of those, only 4 words are the contracting parties. So company A, company B. Less than 0% actually we have positive data. Everything else is just negative. We have the assignable clause, which I previously showed you. It's only 1 sentence. Again, less than 0%. Now, on the overall, when we say we have quite a lot of unlabeled data, but only 1% of our training data is actually annotated, and around 2 to 3% of the contracts actually contain annotations. So you can imagine that the rest of the contract, like 97% in some contracts or documents, 100% is a negative data. We also have some of our annotations about the legal concept. They're not found everywhere. They are not ubiquitous. They just, especially like the most favorite nations, doesn't matter, just some kind of clause, is found only 10%, only a certain type of documents. So this also is something basically like really searching for the needle in the haystack. And again, this is, the imbalancing, which is really problematic, the imbalanced data set, and how do you actually learn from that one? And the problem is like imbalanced learning, the definition is that when you have the learning process where the class distribution, there is a severe skewness. And in our cases, we had now 1% positive and 99% negative, but it could be even more. Now, I want to show you also that there is not only like differences between the two classes, the positive and negative, but we also have within the class. So assignment or assignable is one example like that. For example, it usually is divided into three things: the right to assign something, or under a certain condition, or you don't give the right to assign. Now, in our training data set, which we have, for example, with this one that contains, we have 200, so assignment. But what we see here is that the right to assign is significantly larger. Conditional is very, very small. Now, what would that mean is that actually, if you have those small negative conditional assignment, and you need to actually identify even that one, you will have quite a lot of negative effect on predicting that. You know, if you have the majority, if this was my right to assign, you can live up with a few. If this, let's suppose this one circle is my training data set, and this is the predicted, the transparent one. So you may end up with around 10% error rate on predicting the majority class. Now, the conditional assignment, which is here, might end up with around 50% error rate. And this is already problematic. You know, it's like how you do it. Introduce noise to that data set, and then you end up here, and the numbers would be even worse. You know, here you can live up with noise for the majority. Here in the the minority class, you actually will fail drastically. So and what I want to say, so the final thing that I really want to say is that when you know this skewed distribution of your data, you should really think very carefully when you design your experiments, when you design your training data sets, when you do the testing as well. So you should always take care to represent the natural distribution in the data when you do, let's say, a five-fold cross-validation. So really, when you bin your data, try to, so that it represents the natural scale. But don't do something like, you know, something skewed in order for you to get better results or something. And there is even another worst case scenario, or actually a very interesting case, if you can, for this imbalanced data set. What if you only learn from positive data? What if you just have positive instances? You know that when you let your classifier out there in the world, it will actually be exposed to a lot of negatives. And this is a very interesting problem, which I didn't have time to actually put here. But just to conclude this one, you just like using the kind of, or rephrasing the art of war citation, know your data, know your domain, and you will gain victory in 100 out of 100. So when you gather your data, review it, you know, clean it, define it, look at the definitions, are they still the same, and repeat this process and let your data be live and kicking. It's very important as well for the imbalanced data set. This is really something that we haven't heard so many talk about it, and it is really ubiquitous around us. And so thank you for listening, and questions.
Yes, thank you very much.